So transformations. Again, we're going to do some basic notes first. I'll do more talking than actual writing. So don't expect to get a whole lot in terms of notes. There's a lot of different ways that you can write and talk about transformations. Some of the methods you'll probably see on the FSA. Some of them I highly doubt you'll see. First off, though, we need to talk about the main types of transformations. So how many transformations did we talk about this year?
I think several.
Several, you said? How many total?
3.
All right, there's 3 of one type, and then there was another type. So there's 4 total.
Oh.
All right. Can you name any?
Like
So types of transformations. Rotation. All right. So those first 3 that you just listed. Hold on. Let me write those down first. So I heard translation, a rotation, and I heard a reflection. Now, these are the 3 that get grouped together. There's one other one. What's the other one? Starts with a D. Dilation. Now, those 3 get grouped together. All right. This one is completely separate. Why do those first 3 get grouped together? They don't change the size. So they remain congruent. All right, so they're going to be the same shape and same size. Now, there was a name for that. Yes, you could say they're congruent transformations, but there's a specific name. Rigid motion. All right, so rigid motion, which is another way of saying that you have a congruent transformation. All right. Now, a dilation is non-rigid motion. All right. But what do we know about a dilation? All right. The size can change, but how? The shape stays the same, so they are said to be what type of figures? Similar. So where those are congruent transformations, this would be a similar transformation. All right. Again, there are a few more basics. Let's stick with dilation for just a second. Scale factor, which scale factor, which starts with which is usually abbreviated with a K. All right. If your K is greater than 1, what type of transformation is it? Or what type of dilation, I should say.
what does K mean?
Scale factor. If their scale factor is greater than 1, the correct term is enlargement. Where if K is between 0 and 1, it's a reduction. Is everybody paying attention?
Yes.
All right. So again, what happens if K is 1, or your scale factor is 1? It stays the same. So again, it is possible to have a dilation that is congruent. The only time that's going to happen, though, is if your scale factor is 1, because then that's not going to change the size.
So then that's not a dilation.
Again, you could still call it a dilation of a scale factor of 1, and then it would be the same size. Because remember, 2 congruent shapes are still similar, right?
Yeah.
The sides are still proportional, angles are still congruent. So they still fall under the rules of similar figures.
So when K is equal to 1, it stays the same?
K is equal to 1, it doesn't change the size, yeah. All right, now, there is lots of different ways to write some of these things. I'm just going to use our translation to talk about a few different ways, because the translation probably has the most ways of writing things out.
Translation is the hardest one.
So translation is the one where you slide the image, left, right, up, or down. Now, there are several different ways of writing that. So, for example, let's say we are going right 2 and up 1. If we went right 2 and up 1, there are actually 3 other ways that we can write that. We can write it using our notation with our x and y. So if x, y, then x plus 2, y plus 1. Meaning that we are adding 2 to the x value, adding 1 to the y value. So that's going to give us a shift to the right 2 and a shift up of 1. All right? Now, another way of writing it is by doing a vector notation. Again, I don't think they'll have the vector on there. Let me scoot that up a little bit. So I don't think they'll use the vector notation. But again, I showed it to you just in case, right? So again, that also means that you're going right 2, up 1. Then you also have the function notation that Springboard loved to use with the big T, and then you had the parentheses, x plus 2, x plus 1. Both of these are actually called function notation, and they're very similar to one another, right? They're actually saying the exact same thing. They're telling you how you're changing x and how you're changing y. It's just a little bit different in the way it's written. That says up. Yeah, not no problem. That says up. All right. Any other questions? All right. So, now, is there... Could we be writing notes on this all day? Yes. Again, I'm going to try and mention other things as we go through some of these problems because there's a lot of other information. All right. For example, when we do scale factor and you're talking about image to pre-image, which one goes on top? Image over pre-image. The new over the old. All right. All right. Now, on this first one. Now, this first question is kind of basic, but we could add some other things to this. So they give us 2 diagrams. They tell us in the directions that the shaded image is our what? Is it the image or the pre-image?
It's the image.
It's the image. So again, you got to read the directions though in order to know which one's which here. So this is the image. This is the pre-image. Now, guys, again, a lot of times they might tell you this one of 2 ways. They might tell you which one's the image or pre-image in the directions, and that means you have to read the directions. The other thing that they might do is label the figure. So again, make sure you look at your figure. What is one other way that they could label a figure to tell you whether it's the image or pre-image?
What's the notation?
The notation, the primes. So let's say for a second that I called this one A, B, C, D. All right?
Oh, yeah, the prime.
Well, then when we rotate it over here, it would be A prime, B prime, C prime, D prime. Right? Again, that's another way that they could note how it went from pre-image to image. When it has the primes on it, the primes are for the image, the new figure. If you moved a figure more than once, did a composite transformation, meaning you did more than one, then you could end up with not just prime, but like double prime. Right? So again, you could see those things on the FSA. These are all notations we did way back at the beginning of the year. Now, on here, it's a pretty generic question. First thing they want to know, is it rigid or non-rigid? That's what all the answers have in it, right? So, rigid or non-rigid?
Rigid.
Why do you say rigid?
Because the size doesn't change.
Because the size doesn't change. Is it still the same shape?
Yeah.
But it's not facing the same direction.
Yeah. It's a rotation.
Okay, so again, doesn't have to face the same direction. It's a rotation. So if I look at the dimensions here, this is 3 and this is 4. This is 3, this is 4. The fact that it's turned doesn't matter. Again, it's the same shape, same size. It is congruent. So now, if you look at C and D, they both look like good choices. These two say non-rigid, so those are out. But the first one there on C, it says the image and pre-image are the same shape. Do you agree with that? All right, go to D. The image and pre-image are congruent. Do you agree with that?
No. Yes.
I agree with both of those. Which one's correct?
C.
D.
Wait.
Why is it D and not C?
Because it's the same shape and still just be similar. They can be expanded.
Exactly. Again, if you're just it being a same shape doesn't tell us that they are rigid motion. The fact that they are congruent tells us rigid motion. Again, same shape, like you just said, that could be a dilation, right? Again, same shape, dilations are the same shape, they are not rigid motion. So again, you don't have to necessarily, you got to be very careful when it comes to multiple choice questions. And I'm not going to say that this is the type of question on the FSA that does this, but I would say almost every year there is a question that will be, give you some good options and have like the first part of it correct, but then the explanations differ. And you got to pick the one that fits what it's actually explaining. Because here, again, both of those are true statements, but only one of them is explaining why it's rigid motion. Right? So again, make sure you read all your answers, because it's very possible that, hey, if C was up there on A instead, how many of you guys probably would have picked it without reading all the way down to D? Oh, come on. None of you would have picked it? Yeah, there's a good chance that if you saw that up there as A, and like, oh, that's correct, circle it. But again, read it. Read through it. Be careful. Yes?
So it's congruent because it just rotated it and not...
They're the same. Again, congruent means they're the same shape and size. Okay. We looked at the dimensions. They are the same size there as well. So not only are they the same shape, but they're the same size. That's what makes it congruent.
You're just saying that they're the same shape, but they could come out there.
Correct, because it could be an enlargement or a reduction, stay the same shape. All right. Next. So now on this one, again, read your question and then look at your answer choices. Because again, there's some things you can throw out right away. Look at this. What direction is this going? Right and down. So I'm going to write that right there, right and down. Now, looking at this, again, this starts centered at the y-axis. So if it's not going right, throw it out. Which ones don't go right? C and D go to the left, so those don't work. Which ones don't go down? A doesn't go down, and C doesn't go down. So the only one there that does both is B. Do I even have to look at the values as to how far they went? No. So again, some questions you might be able to answer fairly quickly without doing all the work, right? So again, guys, make sure you look at your questions, make sure you use your context clues, and again, start with the basics. See if you can narrow it down first and find the correct answer. Because sometimes you can find the correct answer faster than actually working it out completely.
Is it okay? So if it's a question you don't know, is it best like try to see the one that they have similar and the one that makes no sense and cross that one out? And do you see that they have similar numbers? You just randomly choose one.
It is so. Testing strategies, I would say that normally if there are two questions that are very similar, or two answer choices that are very similar, usually one of the similar ones is the correct answer. But is that always true?
No. That one, like, okay.
So sometimes that doesn't work, but does that happen a lot of the times? Yes. All right. On this next one, which composition shows that the figures are congruent? So only one of these works completely. All right. So on this one, let's just go from the bottom up. All right. If I rotate this one 180 degrees, what quadrant is it going to end up in? So it's currently here. Or actually, I would be going this way. It's going to end up down here, right?
Yeah.
So it's going to look something like this. Now, you could actually turn your paper to help see it. But it looks something like that. Then reflect over the y equals 0. What line is y equals 0?
It's right there.
Oh, that's the...
Y equals 0 is the x-axis, whereas the y-axis is x equals 0. Right? Because, again, when you do a horizontal line, horizontal lines equal y because it's going through the y-axis at that value. Vertical lines are equal to x because it's going through the x-axis at those values. Right? A vertical line has the same x value at every single point. A horizontal line has the same y value at every single point. So again, those are kind of opposites when you think of them in your head. But again, think about what line is going through, what it's passing through. Again, it's that value's remaining the same. All right. So now on this one, so if I reflect that over, is it going to be in the right spot? No. So it doesn't work. All right. What about C? Well, this one says translate then 2 units over to the right and then 8 units up. Well, I am going to the right and I am going up. Would that work?
No.
No. That's too high and it wouldn't be facing in the correct direction. So that doesn't work. All right. Translate 2 units to the right. So it's going over this way and then reflect over x equals 0. So I'm moving over this way, but then reflecting it, it'd be back to where it started. Doesn't work. This one's almost exactly the same, but it's reversed. So flipping it, and when I flip it, it would be here. And then translate 2 units over to the right, and it would match up. And that's the correct answer. All right. So again, you got to kind of work it out. All right.
Can you go over the 90 thing? It's like it could be negative rotation of 90, negative 180, whatever.
Yeah, we're going to do some of those. Hold on. All right. So on the next one here. Now, they give us coordinates of A and B. They give us B's location in the image. They don't talk about A at all after that. Do we need A? No. So, again, I don't get confused and use A accidentally on a question like this. Because, again, there could be questions where they give you numerous points and then tell you you're doing something with those points and you're trying to figure out what the translation is. Here, they didn't give us any more information about that one. So, you're not using it. We're only focused on B. So for B, we have 1 and negative 1 as the original pre-image. Negative 1, 1 as the image. Now it also said that these have to be congruent. So that means this is rigid motion. Are there any of those answer choices that we can throw out just because they're not rigid motion?
Wait, what?
Why B and D? You're right. Why do those get thrown out right away?
Because they're multiplying y.
Multiplying.
That.
Multiplying is only going to be if you're doing some type of dilation, right? We're not going to change the size, so we can't multiply. So those two are out. Now, is it possible that they could give you one like that and you get the correct value for the point with that multiplying? Yeah, so again, you got to be careful. Now, the two that are left, all we got to do is check them. Plug the values in. See if they give us the right answer. So on this one, if I plug 1 and negative 1 in, I'd have 1 minus 8, comma, negative 1 minus 4. If I plugged in up here, negative 1, comma, negative 1 minus 2. Which one is going to give me this? Well, if I subtract 8, is that even remotely close to being negative 1? No. What about this one?
Yeah.
Negative 1. Hey, we're good on x. The other one, negative and a negative become a positive. Positive 1 minus 2 is negative 1. That one works. Alright. Okay, next. Alright, here we go. This one, again, make sure you read the question. Which one does not work? Which one is not a vertex? Again, a lot of times you'll see some questions probably that use the word not. So don't get caught up and select the wrong answer because it's actually the correct answer. Does that make sense? So on here, we have 4 points. All 4 of these points need to be translated by this vector. So minus 2 and plus 1. So subtract 2, that's negative 5. Add 1, that's 4. 5, 4. Is that down there?
Yes.
Yes, it's down there. And it's a correct answer. So again, we're not going to select it as the answer because we want the one that does not work.
Please switch to a not tying pen.
On this one, minus 2, that's negative 5. Plus 1 is 1. Is that down there? Negative 5 comma 1? Yep, that one works. So again, not our answer. 3, 0. Subtract 2, you get negative 1. Add 1, you get 1. Is that down there?
No.
No. So that's the one that they probably did wrong. So now we have one last point. Minus 2. Thank you. All for tomorrow? Wow, that's a lot. All right. Thank you. Oh. Oh, yep. That looks better. Thank you. So now, on here we have minus 2. So that's going to be 1. Plus 1 is 4. Is that down there?
Yeah.
Yes. So again, that's not the answer. This is the only one that's not one of the vertices. Huh?
That was down 2.
I don't think so.
Or is it just 1 because of this tree?
No, no.
We have line up and
No. All right. On here. So now, the top one. Which are examples of rigid motion? So again, you can throw some things out right away. Which ones would not be examples? Say again? B and C. Because again, they're multiplying, they're not rigid. The only things that apply to rigid is you can change the signs and you can add and subtract. Other than that, you cannot multiply, you cannot divide. So these two would be examples of rigid motion. All right. On the smiley face down there. Now we're rotating. Again, when we rotate, what direction is a positive rotation?
counterclockwise.
So counterclockwise, don't use right and left. Counterclockwise is positive. Again, if you have trouble remembering this, think about your coordinate plane. Anytime we do a rotation, we start at the positive x-axis, and then we go around counterclockwise. Again, your quadrants are named the same way, right? You start from the top left. Sorry, I'm facing the wrong direction. You start from the top right, and you go around this way, right? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Right? Same thing. So again, you go counterclockwise when naming things on a coordinate plane. Same thing goes for any angle.
So when it's positive, go counter, go to the actual direction of the counter.
Counterclockwise,
And then
counterclockwise is positive, clockwise is negative. Now, could they switch it up and be like negative degree clockwise, and then you go counterclockwise? Yeah, again. But if there's no direction with it except for that sign, again, it starts off as positive is counterclockwise, negative is clockwise. So, going from this face to this face, what two work?
E and
Not E.
not?
Mm-mm.
Oh,
C does. No.
C.
Is it? I said C works. I agree with C. So what other one would work with C? F. Alright, because again, if we were to rotate this 90 degrees, it's a negative, 90 degrees clockwise. Look, there's my smiley face. That's the one that we had there, right? If I went all the way around, again, keep an eye on this smiley, not this one. 270 degrees, same thing. Again, if you need to draw a picture on your paper and rotate it, you get scratch paper. Draw it out, rotate your paper. All right? All right, here we go. Some reflections. Now, we got to remember how these things change. Now, remember, if all else fails, draw it. On any reflection, remember, the distance any point is from the line that we're reflecting across is then the same on the opposite side when you reflect it. So if you just draw a perpendicular line and go straight across from it, you should end up at your next point. Now, there are some rules when we have reflections on either one of our two axes or at the line y is equal to x. So we have properties for these three. Given a value of xy, if we cross the line y equals 0, which is our x-axis, what changes about this? Negative x. You have backwards. So again, if look, this is our x-axis, horizontal, right? So if the point's up here, goes down here. What's changing? Again, y equals 0 is the x-axis.
Oh.
Alright, so it's the y value that's changing. the x equals 0, that's our y-axis. So what's changing?
That was the one that I want.
Yeah, so this is negative x comma y. The last one, what happens with the xy coordinate?
I don't like it.
It's an inverse function. It
Does it go to, instead of being xy, it goes to yx?
yx. It switches.
Wait, I hate it.
All right. Question so far.
Wait, what about y equals x?
Say again?
What about y equals x?
Y equals x. That's what I just did. Switch. Yeah. Switch. That's it.
So what would be the answer?
So, we're going to do answers now. So, on this first one, we're changing the y value. So, it'd be 4 positive 2. On this one, we're changing the x value. So, negative 4, negative 2. On this one, we're switching them. So, negative 2, positive 4. All right. Now, again, if you need to, draw it. All right. Remember, a lot of these things seem easier if you draw a picture and do it on your paper. All right. Look, we got primes. So which one's the image? Which one's the pre-image?
The bottom one.
The bottom one?
No,
This is the image?
that's the
Pre-image. This is our image. So it's going from here to here.
The bottom.
Again, it's important to know which one's which because we got to draw some arrows and figure out, hey, which direction are we going? So how many units over and then up did we go?
You went over 3 and you went up 3, so it's
So-
like positive, positive.
So 2 positives, that's D. Now, if you got it wrong because you forgot which one was the image and pre-image, would you have picked the wrong answer? Yeah, you would pick B, and that's wrong. So again, make sure you remember, the pre-image is the one without the primes. The image is the one with the primes. All right. All right. Okay. So, we have our arrow. Again, could you draw this on your paper and just rotate your paper? Yeah. So again, draw it on your paper, and then we have the arrow. We're going to rotate it 270 degrees about the origin. Am I going clockwise or counterclockwise?
Counterclockwise.
All right, so here we go. 90, 180, 270. What way is it pointing?
West.
West. That's my answer.
Northwest.
All right, we good? Stop spraying them. All right, on this one. So now, reflect across the x and then translate along a vector of 4, 1. So first, if we reflect across the x, this becomes down here now. Oops. M prime, L prime. And then a vector of 4, 1. So it means over 4, up 1. So this is there, and this is there. Oops, sorry, that was M. L. What quadrant is that in? 4. Remember, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4.
Wait a moment, I thought it was the other way.
Starts here, positive, positive, and goes counterclockwise when naming them. Always counterclockwise.
I am mad now that I mixed that up. I don't know how that happened.
All right.
Great.
I don't know if we're going to be able to finish this one, but let's try it. So on this one, labeling. Now, guys, you can have a problem like this. If you remember, there is like drag and drop sometimes with letters. So on here, they could give you like an A prime, a B prime, and you could actually have to drag it and drop it onto the correct dot. So here, A, B, C, and D. It says that we rotate it first 180 degrees. So let me draw it. If we were to rotate it, it'd be right here. And it's rotated. So this would be A prime. This would be, let's flip it around so we can see A, B, C, D, like that. All right? So A, B, C, and D. But then we're dropping it down here, vector of 1, negative 3. So now this is A double prime, B double prime, C double prime, D double prime. And this is what we're looking for. Any questions there? All right, bell's getting ready to ring. Again, tomorrow, since most of you guys are in AP testing, I'll just go over random miscellaneous questions that you guys have for those of you that are here. And then on Wednesday, we'll do circles.